Understanding static charges was of course very interesting, but they as such are of not much use. Exciting things really happen when these charges they start moving, and that's when we come to the current electricity. So now let's understand how to get these charges actually moving. So we already understood that we can create separation of charges, so the charges can be separated. We can create positive as well as negative charges. So I have two jars here. Now somehow, right, just let's just suppose somehow I have managed to fill one of these jars with positive charges and the other one with negative charges, right? So what I did was essentially I took out electrons from this jar and I put them in the other one. Okay, so this is, let's say that this is jar 1, this is jar 2. I took out electrons from jar 1 and I pushed them into jar 2. As you can understand, initially when I am moving the first electron, it would be relatively very easy because there is no charge in jar 2. The jar 2 is completely empty. So the first electron I should be able to pry away from jar 1. I should be able to take it from jar 1 and put it in jar 2 relatively easily. The second electron, when I am trying to do that, I would require a little bit more energy. Why is that? Because jar 1 is already positively charged. There is a positive charge right there. So I have to use some energy to pry away the electron, which is negative. So positive, negative, they attract. So I have to use some energy to pry away the electron. And then when I'm trying to insert it into jar 2, I would need still more energy because the jar 2 is negative, and negative, negative, they would be repelling. So I use a little more energy to push it into jar 2. And similarly, the third electron, I would really need to pull it hard from jar 1 and push it really hard in jar 2, right? So slowly and gradually, I would be spending more and more energy as I am taking away the electrons from jar 1 and putting them into jar 2. Okay, so there is the key thing I want you to understand is that when I am doing this charge separation, I need energy. Okay, so there is a need of energy in this process. So this is the first thing that we need to understand. Now let's say that I connect my jar 2 with jar 1 using an electric wire. Okay, so this is a copper wire, normal wire that we see in our households, nothing special. I mean, the special thing about this wire is of course that it can conduct electrons. So what does it mean? That although the electrons cannot really escape, they cannot go into the air, the jar is closed, okay, we don't allow them to escape, they can and they are allowed to travel along this wire. Okay, so there is a wire connecting this negative and the positive charges in the respective jar. So there is a wire connecting that. As soon as I connect this wire, think about what would happen. I mean, think that you are an electron sitting in jar 2. What would you feel? You will feel a lot of repulsion from all the electrons around you. So you would really try to escape. So as soon as I connect this wire, the electrons start escaping from jar 2, and of course they are very happy in jar 1 because there is positive charge there, so they are attracted. So they quickly go into jar 2. Okay, so this is the reverse process. We used up energy when we were separating the charges. We would really need to put some energy, and here the electrons are now traveling on their own. Okay, so that is these electrons which are traveling on their own along the wire can be made to do work. So for example, if I were to connect a light bulb right here, okay, then this light bulb, as the electrons go through it, it will start glowing. Okay, so this is a very simple process of making these charges do some work. Traditionally what happened was, when Benjamin Franklin was doing his experiments, he just assumed that the current was due to positive charges and not really negative. Okay, so the current was not due to, in his times the electrons, they didn't really understand that. So he thought that the current was there, he saw that something was flowing, but he thought that this was positive charges. So although the electronic current, the current due to electrons, is from the negative towards the positive jar, the traditional current, or the current that Benjamin Franklin thought, is in opposite direction. Okay, and this is known as conventional current or just current. Okay, this is in opposite direction. It goes from the positive to negative, and in the electronic current, electrons are flowing, like negative charged particles are flowing. In the conventional current, we say that positively charged particles are going. Okay, so that is the conventional current, and the bottom one is the electronic current. Okay, so this is the key thing that we need to understand. Similarly, we said that in the beginning that when we were separating the charges, we were prying away the electrons from the positive jar and moving them to the negative jar. Okay, this was the electronic way of looking at it. If you look at it conventional way, what we are actually doing, what we would be doing, we would be prying away positive charges from the negative jar, right, from this jar, and putting it into the positive jar. Okay, so we are prying away the positive charges from the negative jar and putting them into the positive jar. Okay, so here what we have done, this is the conventional way of looking at things, and this is actually what we would be using from now onwards. So think about it. Although in actual circuits electron might be flowing, but we always conventionally, when we show in the arrows, we always show the conventional current in which the positive charges are flowing, and that is always in opposite direction. So the equations and everything does not change. It is just the polarity of the charges and the direction of the arrows that changes. Okay, so that so far it is, I hope it is clear. Now our jars 1 and 2, okay, these are what we have labeled them. Okay, let's now introduce some terminology. Okay, so one thing that we introduced was the idea of conventional current. Okay, so that is the conventional current, and it flows from the positively charged jar to the negatively charged jar. Okay, so that is what the conventional current is. That's what we will draw now. And of course, we are prying away the positive particles, positive charges from this negative jar and taking them to the positive jar. Okay, when we are doing this prying away, we are using some energy, okay, to move a charge of 1 coulomb from this negative jar and putting it in the positive jar. We are doing some work. This work is known as the EMF or electromotive force. It is something which is inside the battery. It is the work that the battery is doing to create the charge separation. Okay, it is inside the battery. This EMF is inside the battery. It is the mechanism inside the battery which is creating this charge separation. What happens as a result of this EMF? This work done by the battery is actually available at the 2 terminals of the battery. Okay, so these our 2 jars, the top of the jars are actually 2 terminals of the battery. The 2 terminals of the battery, this work done, the EMF inside the battery is available. The work done inside the battery is available as a potential difference on the 2 terminals, and this potential difference is what drives the electrons or the current from the positive end to negative end. So that work done inside the battery is available outside as potential or the voltage of the battery, and this voltage of the battery drives the electric current and allows us to do all sorts of work. The 2 terminals of the battery, one is positive charge. Okay, so this is the voltage available right here. Okay, I'll just show it here. Voltage, and this voltage you might have seen it inside, like written on the battery, 1.5 volt, 3 volt, 9 volt. Okay, for example, here I have a 9 volt battery right here. Okay, so this is 9 volt battery, and this is the voltage available on the terminals because of the EMF, the work done inside the battery. This terminal which is positively charged, okay, the positive terminal is known as anode of the battery, and the negative terminal is known as cathode of the battery. Okay, and when I connect the anode and the cathode, I can get electric current. Okay, and the current flows from anode to cathode. Now of course, our jar battery, although it's very good for understanding the concepts, it is a little cumbersome. Think about carrying 2 jars and putting them inside a torch or putting them in your cell phones. That would be very, very difficult. So to make things convenient, inside a battery we have these 2 jars. Okay, we still have these 2 jars. They are essentially two separate containers inside the battery, and there is some electrolyte, some chemical inside the battery which is doing the work of separating these charges. So anode is, of course, like we said, is the positive terminal, and the cathode is the negative terminal. The terminal with the bulge is actually positive, that is the anode. And of course there is electrolyte, there is some chemical reaction inside going on inside the battery which continuously separates the charges and makes them available at positives at cathode and negatives at anode. And this voltage is actually available outside the battery, is written in the at the top of the battery on its wrapper, where it says it's 1.5 volt or whatever.